Hi, and welcome to Gaming with EaselJS, an advanced Canvas course on Tuts+. In this lesson, we're going to round out the functionality of our action service and add to it the ability to track mouse position. So let's get started. We'll open up our project folder and fire up the project in the terminal as well using grunt. If you remember from the last lesson, we have our hero and we have an action service that's allowing us to listen to multiple keystrokes, multiple keyboard interactions at once to control our hero using the arrow keys to control our hero. Now for the game that we're going to be developing over the rest of the lessons, we probably won't be using mouse interaction. It's probably going to be just a keyboard and spacebar to fire kind of game. But you could quite easily add some special abilities that need to use the mouse, so some sort of missile that you can choose a point on the screen, a bonus missile or something, and it will make some huge explosion. So it'll be useful to set up mouse interaction anyway. Now there's a challenge we have to face when looking at mouse interaction. We can either listen to mouse movement across the whole window, in which case all of our mouse X and Y coordinates will be relative to the window, and to find out our game coordinates we'd have to do some calculations. Because if we listen to mouse movement only on the canvas, then as soon as the mouse drifts slightly outside of the canvas, it won't be tracking mouse interactions anymore, and that's no good either for a game. So let's open up our Actions module and we'll get started. So the first thing we need to do is add an event listener on the window to mouse move. I'm adding this in the Actions module and in the Actions init function. We'll create a handler called onMouseMove. So in our mouse move handler, we could do the same thing that we do with the rest of our actions, our keyboard actions, and basically set currentActions.mouse equal to an object with information about the mouse move event. So our X position relative to the window is event.clientX. The Y position is client Y. We can include the target for good measure. This is basically whatever element is currently directly under the mouse cursor position. But if we want to include the X and Y position relative to the stage, we're going to have to do a little bit more. We'll leave them null for now and just take a look. So back in our hero on our tick event, where we process our actions, we can console log actions.mouse just to see what information we're getting. So as you can see, while the mouse is over any part of the window, we're getting these events. We're getting our position updated as well, and as you can see down here, it tells you what the current target is. So in this case it's HTML, but now it's the canvas. Great. We can remove that console log, and now let's give ourselves the stage X and Y position. This will obviously be most important for us and the actual game. To do this properly, we're going to need to know what our stage is. So we can actually require that it is passed to the module as an argument. We'll store the stage on a module level variable here. This means though that we'll need to change the name of this argument so that it doesn't shadow the module level variable when we're working with it. So we'll call this current stage. Set stage equal to current stage, and now we'll have access to the stage down here where we prepare our mouse move event. First we'll need to pass it to the action service, which means we'll have to wait until we've prepared our world. Let's make the prepare world function return the stage equals prepare world, and then down here we'll say return stage, and we'll make this a new stage. So now stage is set equal to the result of prepare world, and we can set up our action service here like so. So now we want to get from our stage the canvas element. When we get the canvas element, we can work out its offset within the window so that we can work out the relative coordinates from the window to the stage. So our canvas element equals stage.canvas. If we don't have that, then we simply can't work out these values, so we'll have to return. And our canvas's X position is canvas L dot offset left, and our Y position is offset top. Now we'll warn you, if your canvas is inside another element other than the main body of the document, then you'll have to do a bit more calculation to work out its offset from the top left. But I'll leave that up to you guys. So now we can quite simply set our stage X and stage Y to event.clientX minus canvas X position and event.clientY minus canvas Y position. Oops, I've just made a small mistake. I should be returning in the main.js file the new stage that we've created. Okay, so everything seems normal. Let's go and see if we can make use of this. So just for an example, it might be quite useful to be able to make your hero point in the same direction as your mouse pointer. This could be useful for lots of different types of games. The idea being that as I move my mouse around, the hero would follow and then walk in that direction if I hit forward. So back in our hero class, when we prepare our properties of the hero, we're going to add two more, look X and look Y. Then quite simply, once we've processed the rest of our keyboard actions, we can write if actions.mouse, so if we have mouse events, then this .lookX will equal actions.mouse.stageX, and lookY will be equal to stageY. Then, in our tick event, once we're done processing our hero's position, we're going to call mouseLook and call it with the context of this. So what is our mouseLook function going to do? Well, firstly we need to get our two sets of X and Y coordinates. So X1 and Y is this .X and Y, and X2 and Y2 is the look X and look Y position. Then once again we need to do a little bit of trigonometry. So we need to get the angle of our hero using these X and Y positions. For that we're going to use math.atan2. We need to pass in the difference between Y1 and Y2, the difference between X2 and Y1, convert that from radians to degrees by multiplying the result by 180 divided by math.pi, and then to deal with an offset that we have in our canvas coordinate system, we need to add 90. Then we can simply set our rotation of our hero to that angle. So let's have a look at that. As you can see, the hero is now facing the mouse cursor. And even if I go outside of the boundaries of the canvas, it still follows. If I hit forward now, the hero will go in the direction of the mouse cursor. As you can see, this is quite a fun effect and could definitely be useful for many types of games. As I said, for our particular game we won't be using this, so I'll be removing it for the next lesson. And that's all there is for this lesson. Check back in for the next lesson where we'll be taking a look at the game camera and how we can simulate the effect of a camera that follows our hero through a world that is larger than the canvas boundary. Ciao!